Hey guys, welcome back to another math lesson with HKM Math and Science. This video will be about using graphs to solve linear equations. And by the end of this lesson, we should all understand that each point on a graph represents a solution to an equation relating x and y, be able to solve a linear equation using a graph, and finally be able to understand that the point of intersection is the only solution for both equations. So just pause the video here and take a couple of minutes to write these down. Alright, so there's a couple of key things we need to know to start us off. So the first point is that when given a y-coordinate, the x-coordinate of each point on the graph of a straight line is a solution to a particular linear equation. So an example here, we're given an equation here, y equals 2x minus 1, and we're told that y equals 4. So the x-coordinate, x here, will be the solution when we substitute that y into the rule. So we've substituted 4 into the y here. I'll just rewrite it over here. Y equals 2x minus 1. I'm going to substitute 4 into y. That gives me 4 equals 2x minus y. And now we're going to solve algebraically for x, so that will be the solution. Now I need to get rid of the 1 on the right. So I have to add 1 to both sides. That will give me 5 equals 2x. And now we need to get rid of the 2 on the right. So I'm going to divide it by 2, and that gives me x equals 2.5 there. So in this case, x is the solution when we have the y for the rule. So therefore the point 2.54 shows that x equals 2.5 is the solution to 2x minus 1 equals 4. So that's the same as this over here. And adding on to that, a point xy is a solution to the equation for a line if its coordinates make the equation true. So an equation is true when the left hand side equals the right hand side after the coordinates are substituted. So in this case, we have the rule here. I'm going to go with this rule again. Y equals 2x minus 1. If we substitute these points into the equation there, so 4 into y, 4 equals 2 times x is 2.5 minus 1. That will give me 4 equals 2 times 2.5 is 5 minus 1, and 4 equals 4 here. So in this case, the left hand side, or LHS, and the right hand side, RHS, these two are equal. They're 4 on both sides. So that satisfies this first point here. So an equation is true when the left hand side is equal to the right hand side after the coordinates are substituted. Every point on the straight line is a solution to the equation for that line. So anything that's on the straight line here will be a solution for that equation, and every point that is not on the straight line, so something that might be like out here or out here or out here, is not a solution to the equation for that line. Alright, so using our knowledge that we've just learned, let's use the graph of y equals 2x plus 1 shown here to solve each of the following equations. So remember, this is our equation up here, y equals 2x plus 1. So all they've done for each of these is substitute something into the y. So if you look at it, this can be rewritten like 2x plus 1 equals y. Now you can kind of see the similarity between these two equations. And you'll be able to see that each time they've just replaced the y with a value here. So like we did before previously, we could solve for x. Like in this case, we can rearrange. We can go 2x plus 1 equals 5. Move the 1 over, that gives me 2x plus 1 minus 1 equals 5 minus 1. That gives me 2x equals 4, so x would equal 2. And so for question A, we will know that x equals 2. But when you're given the graph like this, there's another way to do that. We have 2x plus 1 equals 5, so we know that the y value was 5. We just need to move to the right until we hit the line. So we're going to know. With that method, we also know that x equals 2 here. So when you're given the graph like here in this equation, it's actually much easier. Let's try question B now. 2x plus 1 equals 0. Let's try the method I just taught you guys. So y is going to equal 0 in this case, there. So we're just going to move either way until we hit the line. This time will be to the left. And we know x equals right there. And that point is right between the 0 and the negative 1. So that will be negative 0.5, or you could write negative 1/2. Either one is fine there. And moving on to question C, we have 2x plus 1 equals negative 4. So our y value is negative 4. So go to y equals negative 4. Go to the left until you hit the line, and that is right in between the negative 2 and the negative 3, so that will be negative 2.5 or negative 2.5. Either one's fine here as well. Alright, now pause the video here. It's your turn. Take a moment to work this one by yourself, and once you're done, just unpause the video to go through it with me. Alright, so remember once again our rules up here, y equals 2x minus 1. I'm just going to rewrite it so it looks a bit nicer. 2x minus 1 equals y, so the y they're in line now. So we know this side is what's been substituted into the y. So the first time I'm going to find y equals 3 for question A on the graph. So y equals 3 is here. sorry, here, that's the y. I'm going to move to the right until I hit the line, and that's when x equals 2. So for A, it'll be x equals 2. Same thing for B. That's when y equals 0. There we go. I'm just going to move to the right until we hit the line. That's right in between the 0 and the 1. So I'll just say it's 0.5. X equals 0.5 or a half. Either one's fine again. And C, y equals -4. That's down here. And we actually don't, I'm sorry, that's down here. That's the x-axis. Y equals -4 is down here. Go to the left until you hit the line. That's right in between the -1 and the 2. So that will be -1.5 or -1.5. Give a tick for each one you got correct there. Alright, now moving on to the next part. The point of intersection of two straight lines is the only solution that satisfies both equations. So this happens when there are two sets of equations. The point of intersection is the shared point where two straight lines cross each other. So that's like right there. And this is the only point with coordinates that make both the equations true. Alright, so for example, 1, 3, in this case here, so 1, 3 is the only point that makes both y equals 6 minus 3x here and 2x plus 1 true. We know that because that's a point of intersection, and if you substitute 1, 3 into both of these, like you can see here, substitute 3 into the y and 1 into the x, we have 3 equals 6 minus 3, and that gives you 3 equals 3. Remember, left hand side and right hand side equal each other, so it's true. Same with this case, substitute 3 into the y and the 1 into the x. That gives me 3 equals 2 times 1 plus 1, which gives me 3 equals 3. Once again, left hand side and right hand side equal each other, meaning that it is true. Alright, now let's have a go at a couple of questions. This one says use the graphs of y equals 4 minus x and y equals 2x plus 1 shown here to answer these questions. So question A, write the coordinates of 4 points x, y for the line with the equation y equals 4 minus x. So that could be any 4 points that are on this blue line here. That's y equals 4 minus x. So let's have a go at that. Let's start with this one. That's -2, 6. Another one would be, let's say here, let's go 0, 4. Another one, I'll go 1, 3. And another one, let's go 3, 1. So you could have had different points. As long as it's on this line, that is perfectly fine. Next question, write the coordinates of 4 points x, y for the line with the equation y equals 2x plus 1. So that's the same deal, but this time on the red line. Let's start off with this one. 2, 5. Another one, 1, 3. Another one, 0, 1. And another one, let's go -1, -1. So once again, as long as it's on the red line and you have a different point, it's perfectly fine. Question C, write the solution x, y that is true for both lines and show that it satisfies both line equations. So in this case, that would be the point of intersection here, that is right here, and that would be 1, 3. And the next part of the question is to show that it satisfies both line equations. So we need to substitute these values into both these equations. So we have y equals 4 minus x. That'll be 3 is the y coordinate, so I'm going to substitute that into here. 3 equals 4 minus 1, and that gives me 3 equals 3. So left hand side equals right hand side, so it does satisfy it. And the next one, y equals 2x plus 1. Let's substitute that as well. So 3 equals 2 times 1 plus 1. That gives me 3 equals 2 plus 1, and that gives me 3 equals 3. So once again, left hand side equals right hand side, so it does satisfy it. And moving on to the last question, we have solved the equation 4 minus x equals 2x plus 1. So I've started off by writing that there. Our first step will be to collect the like terms, so the x's together and the constants together. So I'll start off by moving the negative x to the other side. So to do that, will be 4 minus x plus x equals 2x plus 1 plus x. That gives me 4 equals 3x plus 1 here. Now I need to move the constant to the other side. So I'll minus 1 from both sides. That gives me 3 equals 3x. And now I need x by itself. So divide both sides by 3. I'll continue my working out here. That gives me 1 equals x. There we go. Alright, now it's your turn. Just pause the video here. Have a go at these questions by yourself and just unpause the video when you're ready to go through them with me. First question, write the coordinates of 4 points of the equation y equals 5 minus x. So any 4 points along this blue line is fine, and same with question B. Any 4 points that are on this red line is fine. Moving on to question C now, I'll just rub that out. Write the solution x, y that is true for both lines and show that it satisfies both line equations. So that's the point of intersection, that'll be right here, 2, 3. and let's show that it satisfies it. So I'm going to substitute that into each equation. 3 into the y equals 5 minus x, so 3 into there. That'll be 5 minus 2. That'll be 3 equals 3. Left hand side equals right hand side. Yep, so that's good. And the last one, y equals 2x minus 1. 3 goes into the y again. 3 equals 2 times 2 minus 1. That'll be 3 equals 4 minus 1. That gives me 3 equals 3. Once again, left hand side equals right hand side, so that looks good to me. And the last one, D, solve the equation 5 minus x equals 2x minus 1. So remember, we need to collect the like terms here. So I'm going to get all the x's on the right and the constants on the left again. So we'll do that by adding x to the left to get rid of the negative x. That gives me 2x minus 1 plus x. So I'll have 5 equals 3x minus 1. Need to move the minus 1 across now by adding 1 to both sides. That will give me 6 equals 3x. And now divide both sides by 3 to get that x by itself. I'll continue my working out up here. That gives me 2 equals x, or x equals 2. Give yourself a tick for each one you got correct there. Alright, so that brings us to the end of this video. Thank you guys for watching, and hopefully by now you guys do have a better understanding of that each point on the graph represents a solution to an equation relating x and y, can solve a linear equation using a graph, and finally understand that the point of intersection is the only solution for both equations. Once again, thank you guys for watching, and I'll see you guys all back online.